Welcome all of you. In previous video, we discussed about M.Sc entrance exam pattern, exam syllabus and some basic questions. I give link of that video in description. Here in this video, we discuss about some more interesting questions which is asked in previous entrance exam. So let us start from question number 11. The pale blue cold emission of light observed during oxidation of phosphorus at room temperature is known as a dash dash. Option A, fluorescence. Option B, chemiluminescence. Option C, phosphorescence. And option D, electroluminescence. So let us see one by one. Fluorescence is the emission of radiation from S1, that is singlet excited state, to the ground state within 10 raised to minus 6 seconds. It occurs in fluorides like calcium fluorides, uranium glass, fluorescent eosin dyes, and chlorophyll pigment, etc. Phosphorescence is the emission of radiation from triplet excited state T1 to the ground state S0 within 10 raised to minus 3 seconds. It occurs in phosphorus, sulfides of alkali metals like sodium, potassium, lithium, calcium, etc. Chemiluminescence is the production of visible light due to chemical reactions. For example, oxidation of phosphorus, certain bacteria in decaying wood, firefly, solution of strontium chloride in H2SO4, mixture of pyrogalol and formaldehyde in hydrogen peroxide, etc. Then, electroluminescence is the production of visible light by means of electrical charge. For example, electroluminescent lamp, LEDs, OLEDs, night signal light, etc. So, oxidation of phosphorus is an example of chemiluminescence. Next question. For a gas behaving ideally under the condition of high temperature and low pressure, the compressibility factor Z is equal to dash dash. Option A 1, option B 0, option C infinity, and option D reciprocal of infinity. So, what is ideal gas law? PV is equal to nRT, and this ideal gas law corrected for non-ideality is PV is equal to Z nRT, where Z is equal to PV divided by nRT. Here P is pressure, V is volume of gas, R is gas constant, and T is temperature, and Z is called as the compressibility factor and is not constant value but varies from one gas to another as well as with temperature and pressure of the gas. So if we plot compressibility factor at reduced pressure and at different temperature, then it is observed that at low pressure and at high temperature Z is equal to 1. So option A 1 is the right option. Next question. The molarity of 1000 gram of pure water is dash dash. Option A 100 molar, option B 55.6 molar, option C 1 molar, and option D 18 molar. Molarity is defined as the mass divided by molar mass. So mass is given 1000 gram and molar mass of water is 18 gram is equal to 55.6 mole per liter. So option B is the right option. Next question. Geiger-Nuttall relation is given by dash dash where R is the range of alpha particle and lambda is the decay constant. Option A, lambda is equal to B plus C log to the base 10 of R. Option B, log to the base 10 of lambda is equal to B plus CR. Option C, lambda is equal to B plus C log to the base 10 R. And option D, log to the base 10 lambda is equal to B plus C log to the base 10 R. So Geiger-Nuttall rule states that short-lived isotopes emit more energetic alpha particles than the long-lived ones, and its relation is given by log of lambda is equal to B plus C log of R. Option D is the right option. Next question. In triangular phase diagram, The point on the side of triangle represent dash dash. Option A, one component system. Option B, two component system. Option C, three component system. And option D, none of these. We have to know the triangular phase diagram for three component system. Here any point within the triangle represent the three component system, and any point on the side of triangle represent the two component system. So option B is the right option. Next question. Chemical reaction which proceeds from reactant to product through one or more intermediate stages are called a dash dash reaction. Option A, consecutive. Option B, parallel. Option C, counter. And option D, side reaction. Let us see one by one. What is consecutive or successive reaction? It is the reaction which proceeds through one or more intermediate stages. Parallel, side or competing reaction is the reaction which takes place in more than one way, giving different product. And counter or opposing or reversible reaction is the reaction in which product of chemical reaction react to form original reactant. So option A, consecutive or successive reaction, is the right option. Next question. The reciprocal of transmittance is known as a dash dash. Option A, optical density. Option B, absorbance. Option C, opacity. And option D, extinction coefficient. So transmittance is the fraction of incident light which is transmitted, that is I upon I0, where I0 is the amount of incident light and I is the amount of transmitted light. Its reciprocal is known as the opacity, that is I0 upon I. And log of opacity is known as the optical density, extinction or absorbance. So opacity, option C is the right option. Next question. According to Beer-Lambert's law, on which of the following does absorbance not depend? Option A, color of solution. Option B, distance that the light has traveled through the sample. Option C, extinction coefficient of the sample. And option D, solution concentration. So what is Lambert-Beer's law? That is log of I0 upon I means absorbance is equal to epsilon Cx, where epsilon is extinction coefficient, C is the concentration of solution, and X is the thickness of absorbing medium, that is distance that the light has traveled through the sample. Here all these terms included in Lambert-Beer's law. So color of solution is the right option on which the Lambert-Beer's law is not depend. Next question. Miller indices of diagonal plane of cube are dash dash. Option A 100, option B 110, option C 111, and option D 210. Here diagonal plane is the plane which cut the two axes and parallel to the third axis. Therefore its intercept is 110. Option B is the right option. Next question. Only the light absorbed by the reacting molecule is effective to bring out chemical change is the statement of dash dash law. Option first, Groth-Draper law. Option B, Stark-Einstein law. Option C, Beer's law. And option D, Stokes law. Let us see one by one. What is Stark-Einstein law? Each molecule absorbs single photon of light in primary process. It is also called as a law of chemical equivalence or second law of photochemistry. What is Beer's law? Minus di by dx is equal to k into I into C. That is, when a beam of monochromatic radiation passes through a solution of absorbing medium, then the rate of decrease of intensity with respect to thickness of absorbing medium is proportional to intensity of incident radiation as well as concentration of absorbing solution. Next is Stokes law. It states that in fluorescence, the wavelength of emitted radiation is always longer than the radiation causing it. So, it is the statement of Groth's-Draper law. Option A is the right option. Mm, Thank you for watching this video, guys.